Welcome to the phenomena of solar eclipse, the topic of discussion that we have today. I am Hariom Vats and presently work for Space Education and Research Foundation, Ahmedabad. And this is the website of this. And there are two email addresses. This is of my foundation email address, and this is my personal email address. And the purpose of giving these email addresses are that if you have any question to ask me on this discussion, you can write to any of these email addresses. And I also would like to mention that this is Space Education and Research Foundation works for science popularization. And in the past more than 2 years, it has done several programs, some 22 webinars and some other programs as well. Recently, we conducted an international workshop on space science. And all the presentations of these events, the recorded presentations, are available on this website here. And you are most welcome to make use of these. And before I start the discussion on phenomena of solar eclipse, let me say a few words about which may be of interest to most of you. And that is that there are some very interesting reading material for space science which are available on this website, an international website. And these are, there are short comic books or graphic novels. And these are on topics of aurora, cosmic rays, geomagnetic field, global warming, ozone hole, polar regions, solar wind, and upper atmosphere. These 8 books are very interestingly created and are available there. And these are available in several international languages, which includes Japanese, English, Hindi, Russian, Spanish, Portuguese, and many more. I, in fact, translated these books from English to Hindi. And while translating these in Hindi, which are also available on the same website, I really learned a lot. And that is why I very strongly urge scientists to translate it in other local languages and make use of this resource material on space science. Now let us discuss the phenomena of solar eclipse, especially the event which is going to take place on 21st June 2020. And this eclipse is an annular type of eclipse. And the path of totality, the path of the totality is shown here. This orange color band that you see on the map is the path wherein you will see the annular eclipse of the sun. And to name some of the towns and villages that are there on the path and in India, those are like Behat, Ladwa, Kaithal, Yamuna and Kurukshetra, etc. There are many other places that it will pass through. It will also pass through part of Pakistan, partly India, and then go to China, and then finally end. In this yellow region of the map, which is marked here, where I have mentioned partial, here the partial eclipse will be seen. And this also will vary in percentage as you go from here to here, or from here to here. The partiality will vary, and it will end here. It will be just there and not been there. And in most part of the southern India, the eclipse will not be seen. That is, there will be no solar eclipse here. And in the partiality region, Ahmedabad falls in the partial eclipse region, where it will be more than 77% eclipse, so which is very substantial. And all cities south of say Ahmedabad in this region will have smaller percentage of partiality eclipse, and all areas that are in this area in north of Ahmedabad region will have higher and higher, and of course here it will become full, and there it will be annular eclipse. And let me tell you some detailed information more about Ahmedabad eclipse thing, that it will begin at 10 hours, 10 o'clock at 3 minutes and 43 seconds in the morning hours, and will get maximum at 11:42 minute, and then it will end in the afternoon at 1:32 minute, and that it will be 3 hours and 28 minutes. The total duration of eclipse that can be watched from Ahmedabad is more than 3 hours. And of course, nowadays there are clouds, and this is the time of having cloud because it is rainy season. So it is possible that on that day, partially there may be clouds. So in some part of even this region, or even the orange region, annular part, one may not be able to see the eclipse, but wherever one can see, it is a very interesting, very exciting thing that one can have look at. This is a celestial event which takes place only very, very rarely. And to proceed with the discussion further, the eclipses are of two types. One, the lunar eclipse, and these lunar eclipse can be partial or can be total. Solar eclipse can be of three types. They can be partial, total, and annular. The annular eclipse does not happen as annular eclipse. And before we discuss why the eclipse takes place, how eclipse takes place, let me tell you that our solar system is a sun-centric system. Sun is the star of our solar system, and it has the most mass of the solar system, very massive object. And all the planets, including our Earth, which is shown here, they go around, orbit around the sun. This is the path of the Earth. In a year, it completes one orbit around the sun. And as you all know, that moon is our natural satellite, and that orbits the Earth on this path. So the Earth takes about a year to go around sun, and the moon takes about 28 days to go around. So there will be several rotation of the moon around Earth when Earth makes one complete rotation around the sun. And the rotation of moon around the sun, the rotation of Earth around sun and moon around Earth are the basic regions of the solar and lunar eclipses. Let me tell you how that is. That, as I mentioned, that the Earth go around the sun. Earth orbits the sun. But because we live on the Earth, we feel Earth is the biggest, and sun, moon, and all the celestial objects are smaller. And we, living on the Earth, feel as if everything go around us, around the Earth. And that is why apparently for people living on the earth here, get a feeling that the sun goes in this orbit. The yellow orbit that is shown here is the sun's apparent orbit in a year. And moon actually go around the earth. Moon is our natural satellite. It goes around us. So, and that is by this white orbit that is shown here is the moon's orbit around earth. These two orbits, orbital planes, are not collinear. They are not coplanar. They are not in the same plane. The plane of the moon's orbit and the plane of the sun's apparent orbit are inclined to each other at an angle of about 5 degrees. And that is the region that these two orbits or the planes cross at 2 points. This point here is called ascending node, and this point here is called descending node. In Indian astrology, this is called Rahu and this is called Ketu. Those are virtual positions in the sky and called Rahu and Ketu, but they are actually the crossing point of the orbit of the sun and moon. And the ascending node is when the Earth's moon's orbit go above the sun's orbit, 5 degrees above the sun's orbital plane. And this descending node occurs when the moon's orbit go under the solar orbital plane. When both sun and moon are either in the descending node or ascending node, both are in ascending node or descending node, that is the time that we observe solar eclipse. And if one is in ascending node here and the other one is in the descending node, then we see lunar eclipse. And because when the sun suppose comes close to ascending node in this region somewhere here and the moon comes there, so there will be a solar eclipse. But then in this this region by sun is covered in more than a month's period. So in that the moon will go after, say, about 14 days after, the moon will go to the descending node, and then we will observe lunar eclipse. And in fact, sometimes it may also occur that moon may even come back to the ascending node, and we may have two solar eclipses and one lunar eclipse. But it can also be the other way, that initially when the sun enters one of these nodes, the moon is in the other, near the other node, and so the first one, a lunar eclipse takes place, and then after 14 days, a solar eclipse takes place, and again after 15 days, lunar eclipse may take place. That is the situation now happening. That on 5th June, there was a lunar eclipse that of course was very faint because moon passed through only penumbral region of the shadow of the earth. So it was a very faint sort of wave, but it was there and was partial. And now on 21st, there will be solar eclipse. And again on 5th July, there will be one more lunar eclipse, and that also will be penumbral partial lunar eclipse. So this is basically one region of eclipse to take place. That the orbit of moon and the sun are not coplanar. They make an angle of about 5 degrees and cross at 2 points, and these crossings are the regions when sun and moon are in these regions. That's when the eclipses take place. The second region for eclipse especially the solar eclipse to take place, is the angular diameter. And the angular diameter of any celestial object, or for that matter any object, depends on where from you are observing. Suppose we take this object, which is represented by a star or sun in our case, that we observe it from A, then we will feel that there is a large angle. So this angle is larger. But if you go to a further distance and go to say B, there the angle will be smaller of the same object. And if you have any other object which covers this region, that also, like this is a smaller object which is here, but this also will appear to be of the same angular diameter from B as the larger object this one is. So, and moon in fact is 400 times closer to Earth than sun, or sun is 400 times farther than Earth as moon is. But the other thing is that the sun's diameter, the physical diameter of the sun, is 400 times larger than the diameter of the moon. And that is the reason that for all people, for everyone living on the Earth, we find that the sun and moon both make about half a degree angular diameter, or 30 arcminute. And in fact, if you stretch your hand and raise your thumb will more or less cover the moon and the sun. You can approximately measure the diameters and will realize that they are nearly the same. And so that is why when the sun and moon are on the same node, ascending node or descending node, the moon comes in between the Earth and the sun, and moon covers the large part or total part of the sun, and that's how the solar eclipse takes place. But there is one more thing to this reasoning, and that becomes the third reason that I'm going to discuss here, becomes the reason for annular eclipse to take place. The orbit of Earth around Sun is also not perfect circle. It has slight ellipticity. But the orbit of Moon around Earth has a larger ellipticity. And the elliptical orbits can be explained like this, that if this is the object around which another object is moving in an elliptical orbit, and at one time it will be closer to the object that it is orbiting, and other time it will be farther away from the object around which it is orbiting. In case of Moon, the distance, these points are called apogee and perigee. The perigee for Moon's orbit is around 362,000 kilometers, and apogee is 405,000 kilometers from the Earth. So there is about 10% difference. So whenever Sun is at the apogee, whenever Moon is at the apogee or near apogee, the angular size of the Moon appears a bit smaller. And that is, right now, Moon is going to be near the apogee of its orbit, and that is why its angular diameter will be slightly smaller than that of Sun. And that is why on 21st June, when the Sun, Earth and Moon, they become almost in the same line, and there will be solar eclipse. At that time, the moon will not cover the entire sun, will cover the central part, large central part of the sun, a very bright ring around the of the outer part of the sun, which is not covered by moon, will be visible to us, and that we call as the annular eclipse. And this in fact happens little more rarely than the total solar eclipse, but it does happen. So to pictorially depict how the Earth, Moon and Sun are during partial eclipse, annular eclipse and total eclipse, this is the picture that we see. That in case of partial eclipse, this is our sun here, this is Earth, and moon is there in between, but it is not exactly along the line joining the center of the Earth to the center of the moon, center of the sun, but it is could be slightly under or over, and that is why the shadow, moon will make a shadow, and that shadow, the total shadow will not fall on the Earth, only partial shadow will fall, which we call penumbra, will fall on the Earth. So wherever there is only partial shadow, there the partial eclipse will take place. So we will feel that some part of the sun, it could be large or small, will be covered by moon, and other part of the sun will be easily visible to us, and this is what is called a partial solar eclipse. At the time of total solar eclipse, this is the situation that Earth and Sun, the line joining Sun and the Earth, almost at the center of that line, moon is also situated, and it is not very far. It is not at the moon is not at the apogee of the Earth. It is near perigee or away from apogee. So in that case, the shadow of the moon, which will get created in this direction, will fall on the Earth, and the region where this umbral shadow, the dense shadow of the moon falls on the Earth, that is the region where we will observe total solar eclipse, that the sun, the visible part of the sun will be totally covered, and that time we see like chromosphere and the corona of the sun, which is very exciting and interesting phenomenon. In case of annular eclipse, the moon is at the line joining sun and the Earth, but it is close to the apogee of its orbital path around the Earth, and since it is at apogee, it is a bit farther from the Earth, and in that case the shadow of the Earth, the shadow of the moon does not reach the Earth. It vanishes little before that, and so we see only the annular eclipse, that the internal part of the sun is covered by the moon, but this bright ring around the sun around the moon is visible to us, very bright. So that is what is annular eclipse. Let us discuss what we see during total solar eclipse and annular solar eclipse from the ground. Here I have shown two sequences of image, one shown horizontally here and the other one shown inclined here. So let us first discuss this one, which is the sequence of images that one can take during a total solar eclipse. And before the eclipse, you see the entire sun, and when moon comes closer to it and it starts covering some part of the little part of the sun, you see sun as like this. So this is sun and this is the moon that you are seeing nearby. And then gradually the moon comes further towards the center of the sun, and so the visible part of the sun decreases and decreases and decreases, and when it becomes very, very small part that the sun is visible, then you start seeing the diamond ring like this here for a few seconds. And after the diamond ring and before the totality is a time when a very thin arc of the sun is visible, and at that time on the ground away from the sun you can see beautiful shadows, and these shadows move, and that is called shadow band. And then after that you see the total solar eclipse, during which you can see the chromosphere, the corona, and beautiful corona in which you can see lots of activity going on, streamers going out, and all the any number of eclipse images you see, you will always see a different kind of corona, and corona is highly variable and dynamic part of the sun. And once the totality ends, moon starts going away from the in front, goes to the other side of the sun. Then the same thing repeat in the reverse direction. You see the diamond ring on the opposite side, and you will see diamond ring in that case on this side, like here. And then you will see the partial for almost similar amount of time, and then the moon will totally be outside the sun's photosphere, and you will see the entire sun. And at this time also, before, as soon as the totality ends, you see this shadow band. I will show a movie where the shadow bands are very beautifully recorded, and also the totality recorded. I'll show that. But before that, let us discuss what we see during annular eclipse. That sequence is shown here. And this is the kind of thing that one is going to see on 21st June if the cloud permits. So initially the moon is covering a very small part, just coming closer to the sun. So this is the beginning of the partial solar eclipse, and then it comes further towards the center of the sun, and the partiality increases, and then it increases further, and then at the end you see almost the ring-like structure is formed, and then it totally, you see this bright ring all around the moon. This is moon which has covered the central part of the sun, and the outer rim of the sun is visible, because at the time of annular eclipse, the angular diameter of moon is slightly smaller than that of the sun, few percent. So that much part of the sun, the outer ring, is seen, and this is what is called annular eclipse. And this is what will happen on 21st June soon. And then the moon will move in the opposite direction, will start going out in opposite direction, and you start seeing the partial sun again. And then when moon is totally outside the sun, then you see the sun back. So that is what is seen there. So this is the sequence that we see during partial solar eclipse, total solar eclipse, and the annular eclipse. Let me show you a short clip of total solar eclipse which took place on 23rd November 2003. And the place where this clip was recorded is Maitri, the Indian Antarctic Observatory in near South Pole. And this recording was done by two of my colleagues, Dr. S.P. Bagare and Dr. S.M. Bhandari. So let me show you, let me play this and show you how exciting the observations are and how the scientists who are recording, they are also excited about it. So please listen carefully.
लाइट कम हो गया ना जा रहा है वाह बोर्ड पे रिकॉर्ड कर दिया उधर देखिए अभी समझो और देखिए मैं ये पूरा ले लेता हूँ अब देखो डायमंड रिंग ले लो अब देखो कोरोना देखो Neighbors! My God! My God! Oh my God! Fantastic! अरे क्या ग्लो हो रहा है भाई? दो आ गया वो आया दूसरा वो डायमंड डे आ रहा है प्रोमिनेंस आ रहा है ये देखो देखो आया 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 वाओ वाओ आपका हाथ सीधी रहे पर मेरा तो हाथ ही सीधी नहीं रहता है आ गया
This what you are seeing here, these moving shadows, these are called shadow bands, and they are being recorded on the opposite side of the sun, away from the sun on the earth, and you see them everywhere on the ground. Very exciting, and they are recorded on this screen. And now they have moved the camera towards the sun, and this is the total. You see the diamond ring. And this black that you see in the center here is the moon covering the sun's photosphere. And what you see around moon here is the corona, the bright corona of the sun. And you see these streamers coming out from this in quite large number. And so that is a very exciting thing to look at. And as you have seen in the previous run, the scientists were very excited when they were watching this phenomenon and recording. And this movement that you see is because of the camera. Now you see the diamond ring again at the end of the eclipse. So you see diamond ring at the beginning of the total solar eclipse, at the end of the solar eclipse. And immediately before and after that diamond ring, you see the shadow bands. Now again, they will record the shadow band. Now you see the shadow bands, they are moving in this direction. They are moving because wind is moving. So you see the entire. Now let me give you some suggestions for observing and doing some experiments during the total solar partial and the annular eclipse, especially for the eclipse that we are going to see on 21st June soon. First thing that my suggestion is that you should view this celestial event with safe methods. Like you should either use the eclipse goggles, or you should to watch the sun directly, or you can use the used blackened X-ray films. You can see through them. You can also use telescopes, but don't view the sun directly in there, but make the image, let the image be projected on a screen and see that. So you should not look with the naked eye towards the sun at any time. And you can take photographs by using appropriate filters. You can take photographs of this event and during partial eclipse. And there is also a thing that you can record, you can make images, or you can take under a tree, a dense tree. The tree leaves, in fact, they crisscross each other and make pinhole cameras. And through, in some of the trees, very dense trees under that, if you go on a normal day, you will see the sun's circles. And those circles are made by the pinholes created by the overlap of the leaves of the sun, and many sub-circles you can see. And if there is a breeze going on, you can also see those circles moving on the ground. When you observe when the sun is eclipsed in partial eclipse, like in Ahmedabad, you will see not full circle, but some part of this sun cut by the moon. So those things, and if there is a wind, then those eclipse sun will move. And it becomes most exciting and most wonderful if you are in the path of annular eclipse, in the region where the annular eclipse or the full eclipse will take place. And if you observe there, then there, instead of circular images, you see the rings. And in some of the trees, if there is a wind, you can see those rings moving in back and forth direction, merging each other and all that. So that is a very beautiful experiment that one can do. There is also a possibility of, because the eclipse in Ahmedabad will be something like 77% plus, so there will be a substantial change in the temperature. In the path of annular eclipse, it will be even more. But here also there will be a temperature change which you can record. But in order to appreciate that change, you must record at least one day before, around the same time, at the same place, how the temperature is varying, and also one day after the eclipse. So you should make observation on 20th June, 21st June, and 22nd June, and then compare. And then you will be able to see the effect of the eclipse of sun as the more and more sun is covered by the moon, how the temperature on the ground changes. One can also do more scientific experiments like ionosphere. There will be a substantial effect on the ionosphere of the Earth when the eclipse takes place. There will also be changes in the atmosphere. You can measure ozone. That will also show a change, substantial change during the eclipse, depending on how the eclipse is, how much the percentage of eclipse is. If you do that, these kind of experiments at several places, then you can find the spatial distribution, how different things affect. So those are interesting experiments that people can take part and do it. And of course, observing the celestial event is the most beautiful thing. This is one image that I show here, share with you. It was taken it is taken from the internet. And here you see, this is during partial solar eclipse under the tree. So you see this type of eclipse sun. And if it was a movie, then you will see these kind of structures going back and forth. And if you do the same experiment, I could not get an image of the annular eclipse, though it was recorded by one of my colleagues long back, I think about 10 years back, but we lost that recording. there you see these full rings, and you can see them, number of them aligned, and then because of the wind moving the tree leaves, and so the pinhole cameras that are formed by the crisscrossing of the leaves, they move, and form and deformation of the rings becomes very interesting sequence. Excuse me. Let me also show you one more image under a tree, and here you see these collection of so many partial eclipse images at the ground. And if it was in movie, you could see the motion of these back and forth depending on the direction that the wind is moving. But it's very, very, very interesting to watch under the tree during partial eclipse, as well as, and becomes more interesting if it is a annular eclipse, where you see these rings moving in a group and deforming. And before I close this session, let us also discuss what is there in a lunar eclipse. As I mentioned, that in case of lunar eclipse, the earth comes between sun and the moon. That means the sun is in one node, ascending or descending node, and the moon is in the other node. So, and this what happened on 5th June, and it will again happen on 5th July, that the earth will come between sun and the moon, and the moon's eclipse or the lunar eclipse will take place. And here I have shown that this is sun, and the light from the sun falls on the earth. This is day side, this is night side of the earth, and you see this is the shadow of the earth on the opposite side of the sun. And if the moon on full moon day, the moon is in the night side, fully in the night side. You can observe this moon, and so it will pass through the shadow, and the shadow will be like here. There are two parts of shadow. This is umbral shadow, the dark shadow, and this is partial shadow of the earth, called penumbra. So if the moon passes only through the penumbra, then we call it partial shadow or partial eclipse or penumbral eclipse. But when the moon enters the umbra, here initially there will be partial eclipse of the moon, and when it is fully immersed in the umbra, that is the total lunar eclipse or full eclipse of the moon. And at that time, in fact, moon does not become totally black, that we don't want, but we see moon with red light. Dim red light is seen coming out from the sun. And the reason for this red light on the sun, on the moon, is that earth has an atmosphere all around it, and on the atmosphere the light is falling, and this light, the earth is the atmosphere scatters that light, and the red color is scattered more in the forward direction, and the blue color or the high frequency part of the solar spectrum is deflected, scattered in the perpendicular direction, and more red color is sent in the forward direction. So when the moon is totally in the umbra, though the direct light from the sun does not fall on the moon, but this scattered light falls on the moon, which is dominated by red color, and hence we see red color of the moon, faint red color of the moon. So that also is a very beautiful thing to watch. Of course, the lunar eclipse which took place on 5th June and the one that is going to take place on 5th July will be that the moon will enter only penumbra, which is also all around it. So it will pass through only penumbra. So there will be only very faint partial eclipse of the moon. And during a lunar eclipse, this is the sequence of images that you can make, you can observe. That here on a full moon day, you see moon like this. And when it enters the shadow of the earth, because it is on the same side, and if it enters the shadow, then some part of the moon will get eclipsed, and it will become more. When it enters more toward the center of the shadow, and then further it decreases, and when it goes almost in the innermost part, the central part of the umbra, then it starts turning red, and this is the time that it is totally in the umbral region, and the direct light from the sun is not falling on the moon, and moon is not reflecting the direct sunlight, but it is reflecting the scattered light that comes from the sun only, but it is scattered by the atmosphere, and that scattered portion has more red color, and that is why we see the sun, the moon as of red color here. So here in this, so now we have come to the end, and I must say that several pictures that I have shown in this presentation are taken from the websites. I wish to thank the contributors of these, and I also thank all of you for very patient hearing, and I will be glad to answer questions. You can also ask the questions by sending email to me on any one of these email addresses that I have, my foundation email address and my personal email address. I will be very glad to answer those. So with this, thank you very much.